Feynman says of the experience, after a lot of investigation, I finally figured out that the students had memorized everything, but they didn't know what anything meant. When they heard light that is reflected from a medium with an index, they didn't know that it meant a material such as water. They didn't know that the direction of the light is the direction in which you see something when you're looking at it, and so on. Everything was entirely memorized, yet nothing had been translated into meaningful words. So if I ask, what is Brewster's angle? I'm going into a computer with the right keywords. But if I say, look at the water, nothing happens. They don't have anything filed either. Look at the water. So this observation that he made in his classroom experience was reinforced later when he attended a lecture at an engineering school in Brazil. The teacher was reciting, two bodies are considered equivalent if equal force will produce equal acceleration. Two bodies are considered equivalent if equal force will produce equal acceleration. They're all beautifully writing down this precise formulation. He's slowly repeating it so they can take it down verbatim. So Feynman pulled aside one of the students after the class and asked what they used the notes for. And he said, well, we'll use them to prepare for the test coming up. And he said, so can you give me an example of a question that would be on the test? And he said, yeah, it will have questions like, when are two bodies considered equivalent? Now, you can probably answer that question now. But do you feel really knowledgeable about the subject? Feynman noticed that it was clear that the students had no idea what in reality this principle described, that it concerned objects with the same moment of inertia, and that it would relate to something like the difference between pushing a door with heavy weights on the outside compared to when they're near the hinge. Like the poor student Kevin, they were memorizing empty verbiage and had no idea what it meant. Still other observations connected with this. He observed at an entrance exam for engineering school students that if he asked them to ever apply their knowledge rather than just recite it, they couldn't do it. In his classes, when he would ask them to solve by trial and error, rather than waiting for him to teach them explicitly the method which they could then imitate, they wouldn't do it. When he encouraged them to ask questions in class and to refine and flesh out their understanding of his teaching, they considered that an interruption that was contradictory with what they thought of as learning, and they didn't do it. He says all the work they did, intelligent people, but they got themselves into this funny state of mind, this strange kind of self-propagating education, which is meaningless, utterly meaningless. Now my favorite part of the story. At the end of the year, Feynman was asked to give a talk to the students about his experience teaching in Brazil. And he agreed if they would let him say whatever he wanted. They agreed. So the day of the talk, he walked into the lecture hall and said, the main purpose of my talk is to demonstrate to you that no science is being taught in Brazil. He first pointed out that he had been struck by the observation that if you go into Brazilian bookstores, you'll see small elementary-aged kids buying books on physics. And yet, he didn't see at the time Brazil producing many chemistry. He made an analogy, what was going on in Brazil, he said to imagine that you're a passionate you're a passionate Greek scholar, and you discover that there's this place where everyone is studying Greek, and you go there, and you want to talk to them about Socrates' ideas on truth and beauty, and they look at you absolutely blankly. And then you ask them what Socrates said in the third symposium, and they start reciting all the words to you. But in the third symposium, he's talking about truth and beauty. The words for them are empty of their power, of their relevance, of their meaning. He also pointed out that the physics textbooks in Brazil were devoid of experiments. that in every circumstance they were encouraging nothing but memorization and not real thinking. So he picked up the textbook, turned to a random page in it to prove his point, and found the definition of triboluminescence, which was light emitted when crystals are crushed. What you didn't see was a description of the phenomenon that when you take a lump of sugar and crush it with pliers in the dark, you will see a bluish flash. And that phenomenon that you're observing is referred to as triboluminescence. That approach connects the concept to real life and encourages experiments. I don't know about you, but when I read that, I wanted to go home and try it. Okay, so he delivers this statement about Brazilian science education, finishes his talk, and the head of the science education department stands up and takes the microphone. And he said, quote, "Mr. Feynman has told us some things that are very hard to hear, but it appears to be that he really loves science and is sincere in his criticism. Therefore, I think we should listen to him. I came here knowing we have some sickness in our system of education. What I have learned is that we have a cancer. I wish there were more Feynmans pointing out and more educators heroically recognizing that American science education has this cancer." And in a few minutes you'll hear Mr. Krieger talking about his efforts to offer your children a healthy approach to science. But before I give the floor to Mr. Krieger, I want to introduce you to Dr. Feynman. So, this is a clip from the BBC documentary. Okay, so I just want to highlight one statement from that section. His father would stop and say, "Let's see what that means." It would always be translated into some reality. And he developed from that the habit of doing that himself, of always looking at the information he's taking in and saying, what does that really mean? Do I really understand that? A few highlights from that. Knowing the name, you know absolutely nothing about the bird. So he was taught early on the difference between knowing the name of something and knowing something. That's how he was taught science. Examples and discussion. No pressure. Just lovely, interesting discussion. Well, that's what Dr. Krieger is trying to do with your children. Now, he has taken on the heroic task of turning these principles of this approach into a curriculum. There are very few resources available that take this approach. Maybe to this day, none. But he is passionately dedicated to this purpose, and that's why he's here. And so I'm now going to, with profound gratitude for all he's doing for this school and for our students, turn the floor over to Mr. Krieger, Dr. Krieger, to describe his approach to teaching science.